Give this one a second chance. I've done this one already, all the way to the end and posted it. One of my fine students noticed this and let me know. Actually, a couple of them, a few of them, 3 of them that I know of. So, let's get started. Two sides of a triangle, 6 meters and 8 meters, respectively. Cool, so we know 2 sides of a triangle, not necessarily a right triangle, just a triangle. Cool. 6 and 8. Neat. So we want to just answer A in this one. We'll be to part B in a little while. So part A is how fast is the third side increasing if the angle between the given sides is 60 degrees and it is increasing at a rate of 2 degrees per second? Well, this is the when. This is the when the angle is 60 degrees. It's a when. It's not always going to be 60 if it's opening up. Between those 2 sides, as they're opening and the side's getting larger. Move you right over here. Hey, there's our chimp. She's back. But as our angle gets larger, right, our x is going to change. And so will the angle. So this is the weight. Now, oops. Now this is a little thing we want to do when we're in calculus and we get a question that's talking about degrees. We don't want degrees. We want radians. Radians are lengths. So when we do some fancy footwork, when we take derivatives and plug this stuff in, right? Aren't we going to have like dx dt's and d theta dt's and d yo mama dt's, right? You're going to have to plug these things in and multiply by lengths. You can't be having degree feet. That doesn't make any sense. We need to get them radians in that actually don't have the unit of measure, but they are a length. Come on. So let's convert this thing right away. Now this one actually doesn't make any difference because we're just going to plug it in later. But just getting in the habit of it's going to be a good thing. Also, we have our, we can see that we're going to have some change in the angle, a rate. Anytime you can see it's like with a seconds or minutes or hours, like miles per hour, we know what's up. So we can say that d theta dt is equal to 2 degrees per second. But we'd have to do a little, what's that, like, it's like 180 over pi, and we can convert it into radians, so we can be like, oh, bro, there it is, those degrees cancel out, we just get pi over 90. So we'll use that stuff later. Just showing you, it's probably a good idea to convert that stuff right away. We don't want those 2 degrees. We're not going to use degrees in these word problems, so change that stuff up. All right, let's go back to this triangle we've created. So there we have it. We figured out some rates. We've drawn a picture. We're like, dude, it's just some freaking triangle. Now we need to start going through some of our rules. Maybe do a substitution, but we don't even know how to substitute. Let's come up with some sort of formula. Now this triangle is, it's not a right triangle, and we know 2 different ways of solving triangles. That's the law of sines, but you need an angle in the law of sines. And we don't have one, and this just isn't the right case. We don't have anything across from each other, but the law of cosines I think would work out really great here. So maybe instead of calling this x for a second, maybe just call it c, just so we can kind of take a look and maybe set up some sort of formula. And the law of cosines goes that c squared is equal to a squared plus b squared minus 2ab cosine of c. And I'm going to write in theta instead of c. Hope you're going to be okay with that. Okay. So there we have it. We have our formula here where we can start relating things together. So let's take a look and let's change that c. Now we go back because I don't want to call that thing c. Just call that thing some x and call this thing some x, and all right, let's just see what we got. Let's plug things in. So do you mind if we just say that a is equal to 6 and b is equal to 8? It doesn't matter which one's which. This is just when we have the angle in between something. So now we can go and plug this in. We see that we have our x squared, and that's not going anywhere, plus our a squared, and a squared, that's going to be 6 squared. What's that, 36? Plus our b squared, and that's going to be equal, that's our 64. And then what else do we have? Now we're left with minus our 2, our a times b times cosine of the angle in between. Now our a is equal to 6, right? We pop that in there, and then our b was equal to 8. So let's clean all this stuff up and see what we end up with. But Should we really? You know what I mean? Let's just see what we got. We have x squared is equal to 36 plus 64 is 100. Minus 2 times 6, that's a 12 pack, right? And then if you have 8 12 packs, quick, 96. Let's go. Come on, gotta be better. So we have x squared is equal to 100 minus 96 cosine of theta. We've now created ourselves a little formula that ties everything together. And we want to see, the question one more time is, how fast is the third side increasing? How fast? We're looking for that dx dt. This is what we're going to be looking for, is dx dt. We want to know how fast is the third side increasing if the angle between the sides is 60 degrees and is increasing at a rate of 2 degrees per second. I think we've related some stuff. We have that x, and we're going to want to know what this is. What that change in x with respect to time as this side gets bigger, as the angle gets bigger. Well, let's take a derivative. Now, once we have some sort of relation that's all tied up, we just have two variables, making sure we're not doing any products, chains, quotient, shit like that. Let's go. So we'll take a derivative on x squared, and that's going to become 2x dx dt. Hey, that's what we're looking for. We want dx dt. Derivative on 100 is nothing, and then the derivative on negative 96 cosine of theta is going to be equal to positive 96 sine of theta. D theta dt. Well, what do we have? What do we have? Hey, we have d theta dt. We have theta. Shit, let's go back and plug them in. D theta dt is equal to pi over 90. So that's pi over 90, right? Place that stuff in. We got that. What else do we got? We got the sine of theta. So sine of, didn't we get our theta was pi over 3? I think we call it. We waited long enough. Let's put it in there. We have our 96 over here. We have our 2 times our, oh shit. We're looking for dx dt, right? We know we're not going to find it. We need that x value. Crap, we were so close. Yeah, we need one more variable. Well, I think really the game is going to be we have a formula. It's right up top, you know? It's right there. And we can plug in the when now. We know that theta, we've waited. We've waited this long. When theta is equal to pi over 3, what's this going to equal? Let's go solve for x. Hi, kitty. So we're going to have the x squared is equal to our a squared plus our b squared minus 2 times our a times our b times cosine of that angle. So that angle was pi over 3, working backwards, huh? Right, so we got that our a is equal to 6. Our b is equal to 8. And let's hit it with the square root when we set it all up. So that's 36 plus 64, that's a big 100. We already knew that. 2 times 6 is still 12, and 12 times 8 will give you 96. And now we're left with cosine of pi over 3, and cosine of pi over 3 is equal to 1/2. Here we have it. X is equal to the square root of 100 minus 48. That's going to be equal to 52. Oh, these are cards. So that's 4 times 13. That's 4 times 13. So that's 2 times root 13. 2 times root 13. In my first video, I will change this into a root 3 and screw up the whole damn problem, giving you the wrong solution. So now that we have our 2 root 13, we just want to take it and pop it right back up into there. So what do we get left with? Let's take this aside and let's go. So we have 2 times our 2 root 13 gets popped in, times our dx dt. We'll clean up the other side. We have 96 times sine of pi over 3. Sine of pi over 3 is root 3 over 2. And now we have our pi over 90. Let's try and keep everything exact, y'all. Okay? Now let's mess with the left-hand side. That's 4 root 13. We're about to divide that out. Let's not stress about rationalizing the denominator at the end. We'll get there when we do. A little fancy footwork. Cancel out the 2. Get a 48. We still have an even over an even, so let's cut that in half. We get 24 over 45. Shit, there's still a 3, so we cut it in 3. That's 8. That's 5. So what are we left with? 8 root 3 pi over 5. And then we can clean up over here. And geez, let's do one thing. Let's cancel a couple things out here and go go whack, whack, call that a 2. Now we can divide out that root 13. Gosh, there's so much algebra in this. Root 13, so we're going to find out that our dx dt is equal to 2 root 3 pi over 5 times root 13. And you know what? I'm done. I'm done. I don't give a shit. A calculator can handle this. You can punch that thing in. You can go find your answer. I just need to go figure out what freaking units we're in. We were in meters, and I see some seconds in there. If it's a change in x with respect to time, that better be meters per second. Let's leave it there. If you want to rationalize, gold star for you. I'm going to cut it right here.